my God!
Today, we will use a scientific perspective to explore the complex truth behind meteorological events. According to the latest news from the BBC News website, on February 8th, a volcano in southwestern Iceland erupted violently for the third time since December last year, with lava spewing up to 50 meters high. The eruption began at around 6 a.m. local time and erupted along a 3-kilometer fissure in the northeastern part of the Sunnukar Mountains. Several communities on the Reykjanes Peninsula were cut off from heat and hot water after rivers of lava engulfed supply pipes. The Met Office said the eruption had weakened in intensity by around mid-afternoon, but lava continued to erupt from some cracks and huge plumes of steam rose in parts of the cracks where magma mixed with groundwater. The eruption site was about 4 kilometers northeast of Grindavik, a coastal town of 3,800 people that had been evacuated before the last eruption on December 18th. Thank you for liking, leaving comments, subscribing and turning on the little bell. We will update every day. The pipe, which was destroyed by lava, supplies hot water from the Svartsengi geothermal power plant to several towns on the Reykjanes Peninsula, which is used to heat homes. Authorities urged residents to use hot water and electricity sparingly, and workers were busy laying underground water pipes as backup. With schools, gyms, and swimming pools closed due to a lack of heat and water, Iceland's densely populated community is likely to find itself in dire straits amid the ice and snow. The Blue Lagoon Spa, built using excess water from the power plant, was closed during the eruption and all guests were safely evacuated. A steaming lava flow then spread onto the spa's exit road. Airport operator Iceland said there were no flight disruptions reported near Iceland's main airport in Keflavik, but hot water had been cut off. The Icelandic Meteorological Office warned earlier this week of a possible volcanic eruption after detecting a buildup of magma, or semi-molten rock, underground over the past 3 weeks. Hundreds of small earthquakes have been measured in the area since Friday, with the latest burst of strong seismic activity about 30 minutes before the eruption. In fact, our channel has tracked and reported on the eruptions of Icelandic volcanoes many times in the past 3 months. Among them, on January 14th, the Fagradal volcano in southwest Iceland erupted violently. Lava flow spread all over the city, and when it flowed to the edge of Grindavik harbor, at least 3 houses were set on fire. At the time, the Icelandic Meteorological Office said the eruption occurred just before 8 a.m. local time, and local authorities had evacuated the town's 4,000 residents following a series of minor earthquakes. The Meteorological Service said that on Sunday morning, a crack appeared in the ground about 450 meters away from Grindavik. As of 6:45 p.m., it had become a crack about 900 meters long. According to the office, a second fissure appeared on the edge of town around noon and was about 100 meters long by evening. The flow of lava from both fissures showed no sign of slowing down. Icelandic President Gudnis Jóhannesson called the disaster a black day for the country. At that time, it was the second eruption of the volcano southwest of the capital Reykjavik in less than a month and the 5th volcanic eruption in the North Atlantic country in less than 3 years. In the weeks leading up to the January eruption, the government decided to erect protective walls to try to stop the flow of lava to Grindavik and the nearby Svartsengi geothermal power plant. For the first few hours, the protective wall proved useful, but things took a turn for the worse after that. Tragedy occurred on January 10th when a man working in the town fell from a crack. After a brief search, the operation was stopped due to the danger involved. On December 18th, We also reported that the Reykjanes Peninsula suddenly erupted after weeks of violent seismic activity. The eruption occurred at Mount Haga, a volcano belonging to the Fagradal volcano a few kilometers north of Grindavik. The cracks in the ground are 3.5 kilometers long and are currently expanding rapidly. GPS measurements indicate that the magma is moving southwest or continuing toward Grindavik. At that time, the volcano spewed lava and smoke about 100 meters high. The Icelandic National Broadcasting Service quoted seismologist Jonsdottir as saying that the eruption point spewed magma at a speed of 100 to 200 cubic meters per second. Icelandic police said they had raised the alert level regarding the incident. After emergency personnel's assessment, the Civil Defense Department also warned the public not to approach the volcano area. Our channel has been reporting and warning about volcanic eruptions since early November. On November 12th, we reported that 10,000 earthquakes were recorded on the Reykjanes Peninsula, reaching a peak on Friday night, and residents of the nearby rural town of Grindavik were evacuated. According to the International Maritime Organization, 24,000 earthquakes have occurred on the peninsula since late October. The earthquake cluster indicates that magma has moved through the Earth's crust to 3 to 4 kilometers below the surface, and if it breaks through the surface, it will cause a volcanic eruption. At the time, the head of the Icelandic Civil Protection Agency noted that magma could erupt from anywhere in the 15-kilometer-long fissure near Grindavik. If magma erupts from the sea floor, it can produce dangerous amounts of ash. The volcanic eruption at that time just confirmed the speculations of officials at the time. The Reykjanes Peninsula is located in southwestern Iceland and is one of the most active volcanic areas in the country. From March to September 2021, the Fagradal volcano had a minor eruption here, attracting tens of thousands of tourists to watch the spectacular lava fountain. The Fagradal Mountains are about 5 kilometers wide and 25 kilometers long. The last eruption was in the 13th century. Experts say the magma channel at that time may have been preparing for a new round of volcanic activity. Grindavik is located on the west coast of the Reykjanes Peninsula and is the main fishing port in the area. In addition to fresh fish, nearby geothermal resources also support the town's economy. The town is located about 30 kilometers south of Reykjavik, the capital of Iceland, and has about 3,400 permanent residents. During the evacuation, most residents chose to drive away and go to the homes of relatives in Reykjavik and nearby towns for temporary shelter. Geological activity in this part of Iceland had been dormant for nearly 800 years, until strong seismic activity emerged on the peninsula in early 2020. Magma surged to the surface in 2021, and then only in August 2022 and again in July this year. So far, eruptions have been in remote areas and relatively minor, posing little risk to people or infrastructure. Although Iceland is no stranger to volcanic eruptions, its citizens have not experienced an eruption of this magnitude that threatens residential areas since 1973, when a town of about 5,000 people in the Westman Islands was partially buried under lava. But deaths from volcanic eruptions are rare. One of the most devastating volcanic eruptions in Iceland's recent history occurred in 2010, when the eruption released large amounts of ash and halted air traffic across Europe for weeks, canceling 100,000 flights and affecting more than 10 million people. Iceland is an island country located in the middle of the Atlantic Ocean. It is at the junction of the Eurasian Plate and the North American Plate and belongs to an extremely active tectonic zone. Iceland is surrounded by mid-ocean ridges where submarine volcanoes and plate movements occur most frequently. Iceland itself is a volcanic island with extremely high-temperature magma underground. The magma continues to move upward, causing the pressure at the crater to gradually increase. Once the pressure builds up beyond the rock's endurance, an eruption occurs. At the same time, magma movement also causes cracks to appear on the surface of the Earth, resulting in frequent earthquakes. There are currently about 130 volcanoes in Iceland, including many medium-sized volcanoes that are active all year round, as well as the large volcanoes that symbolize Iceland, Hekla and Katla. These large volcanoes have extremely developed volcanic seepage systems, which can serve as channels for magma to rise, exacerbating the possibility of volcanic eruptions. Historically, Iceland has had many major volcanic events. In 1783 to 1784, the massive eruption of Loki volcano emitted smoke and ash covering the entire northern hemisphere, causing global climate anomalies. In 2010, the Eyjafjallajökull volcano erupted, becoming the largest volcanic activity in Iceland in the past century. Volcanic ash almost flooded the entire eastern part of the island. Just recently, starting in 2021, volcanic activity in southwestern Iceland has once again entered a period of intense activity. First, Grim volcano erupted on March 19th, and then Mount Kira also erupted on March 20th. The two volcanoes echo each other, and a connecting pipe is formed underground. Magma continues to collapse and accumulate, creating increasing pressure between the pipe and the crater, eventually triggering a high-intensity eruption. For more than a year since then, the volcanic belt in southwestern Iceland has continued to be active, with earthquakes and aftershocks occurring one after another. Therefore, the reason why Iceland frequently experiences volcanic eruptions and earthquakes is mainly related to its special geological structure. Mid-ocean ridges make magma movement extremely vigorous, and a large number of volcanoes provide outlets for magma to vent. This makes Iceland one of the most volcanically active areas in the world. Various volcanic events occurred one after another, giving Iceland the reputation of the land of fire and ice. Volcanic eruptions can trigger a series of secondary disasters that require special attention. First of all, when a volcano erupts, a large amount of high-temperature volcanic ash, magma, gas, and ice and snow interact, triggering a large-scale lahar. This kind of volcanic mudflow is extremely destructive. Its flow speed can reach 100 kilometers per hour and its temperature can reach hundreds of degrees Celsius. It can bury surrounding towns and villages in a short period of time. There have been many incidents in history where lahars caused huge losses of life and property. Secondly, another more destructive volcanic secondary hazard is pyroclastic flow. Its essence is a fluid composed of high-temperature solid particles such as volcanic bombs and volcanic ash. The flow rate is faster and the temperature is higher, reaching 700 to 800 degrees Celsius. The history of one of the deadliest natural disasters in the world was a pyroclastic flow on Mount Perrin in 1902, which killed more than 30,000 people. At the same time, mudslides are also a very lethal volcanic secondary disaster. When a large amount of volcanic ash meets water, it will produce a cement-like substance, which will mix with soil, trees, and other debris to form a fluid, which will flow rapidly on the hillside. This kind of debris flow is larger in volume, higher in density, and extremely destructive. Historically, entire villages have been swept away by mudslides. It is worth mentioning that changes in magma movement beneath volcanoes can also trigger large-scale landslides. Part of the mountain near the crater suddenly collapsed after losing support, forming landslides that could reach tens of kilometers and collapse volumes of billions of cubic meters. This can cause entire rivers and valleys to be blocked and cause debris flow disasters. What cannot be ignored is that some large-scale volcanic eruptions can also cause large-scale floods and other hydrological disasters by affecting climate patterns. The Tambora volcano in 1815 is a famous case. The large amount of volcanic ash produced by the eruption blocked the sunlight, causing global temperatures to drop, ultimately resulting in an extremely cold summer with a year without a summer. This also triggered hydrological disasters such as flooding. In the event of a volcanic eruption, personal escape measures are particularly critical. Once a volcanic eruption occurs, the area surrounding the volcano needs to be evacuated quickly. If there is a self-driving vehicle, you can drive to evacuate quickly. If not, you should leave as soon as possible on foot or by other means of transportation. It should be noted that you cannot choose to evacuate in the same direction as the downwind of the volcano, as this will easily be covered by volcanic smoke. The correct approach is to choose the opposite direction to the upwind of the volcano, so as to avoid inhaling volcanic smoke to the greatest extent. Secondly, when evacuating, you need to choose the evacuation location correctly. Residents who live in the downwind direction of the volcano should choose to take refuge in the upwind direction, and cannot choose downwind refuge points, while residents who live in the upwind direction of the volcano should choose the upwind area farthest from the volcano to take refuge. An ideal evacuation site would be an indoor, large building with an air filtration system to isolate volcanic smoke. At the same time, after arriving at the shelter, various protective measures need to be taken. Doors and windows need to be closed inside the house, and door cracks should be blocked with wet towels to prevent volcanic smoke from entering the room. If you need to go out, you must wear an N95 mask or a higher-level respirator, long sleeves, long pants and protective glasses to cover all exposed parts of your skin. In addition, avoid going out for extended periods of time. For areas with frequent volcanic eruptions, a series of disaster prevention and reduction measures can be taken. The first is to strengthen volcano monitoring and establish a volcano early warning system. Arrange seismometers, GPS stations, inclinometers and other equipment in areas around historically active volcanoes to monitor the possibility of harbinger signals from volcanoes and achieve early identification of volcanic activity. Once abnormal signs of the volcano are detected, emergency plans can be quickly launched to evacuate surrounding residents. The second step is to carry out multi-hazard risk assessment. Identify dangerous areas of volcanic secondary disasters and compile risk maps accordingly. Government departments can rely on these research results to formulate urban planning policies for different disaster risk areas and control population gathering in high-risk areas. For existing high-risk gathering areas, it is also necessary to propose construction requirements for planning facilities such as refuge buildings and evacuation passages. At the same time, localized volcanic disaster emergency plans can be refined based on the characteristics and scope of volcanic disasters, and drills can be carried out regularly. The plan needs to specify in detail the monitoring methods, information reporting mechanism, emergency resource allocation, evacuation methods, and the division of responsibilities of various departments and social forces in the event of volcanic anomalies. And test the effectiveness of the plan through simulation exercises. More importantly, The volcanic disaster insurance system must be improved to help residents spread the economic risks of volcanic eruptions. This includes setting up a government-funded minimum living security volcano insurance fund to subsidize residents' commercial volcano insurance costs, or directly providing a government-paid volcano disaster relief fund for residents in poor areas who cannot afford insurance premiums. At present, many new technologies have emerged to address volcano monitoring issues. First of all, satellite remote sensing technology can monitor tiny surface deformations in volcanic areas, which is an important precursor to determining whether a volcano is in an active period. For example, INSAR interferometric imaging can detect millimeter-scale crustal bulges. Thermal infrared detection can monitor volcanic surface temperature changes. Optical or radar satellites can determine the trajectory of volcanic ash eruptions. This information can be used to predict volcanic eruptions. Secondly, solid geophysical monitoring uses various instruments to monitor changes in volcanic harbinger entity signals, such as abnormalities in seismic waves, magnetic fields, etc. These signals contain physical information about the movement of volcanic magma. For example, frequent volcanic microearthquakes indicate that magma is rising. Changes in the magnetic field reflect that magma movement has changed the underground structure. At the same time, monitoring changes in various chemical components in hot springs or gases near volcanoes is also an effective means of predicting eruptions. These chemical compositions can reflect changes in the magma chamber. In recent years, continued measurements of rising concentrations of sulfur dioxide, carbon dioxide, helium, and other components often indicate an imminent volcanic eruption. In addition, machine learning and big data technology are widely used in geological disaster early warning. This type of technology can realize rapid and intelligent analysis of massive monitoring data and realize automatic detection of precursors of volcanic anomalies. In addition, scientists are also exploring the possibility of placing monitoring instruments directly inside the volcano to directly measure the internal state of the volcano. This will undoubtedly greatly improve the effectiveness of volcano monitoring and forecasting. Thank you for liking, leaving a message, subscribing, and turning on the little bell. We will update the latest news from around the world every day. Continue to use a scientific perspective to explore the complex truth behind meteorological events.